Hello, in this simulation we're going to investigate changing the flux by rotating the coil. Here you can see a coil with a large area and few turns of wire. This time the coil can be rotated in the magnetic field between two block magnets. The small diagram on the far right shows a two-dimensional side view of the coil. Let's drag the dial on the left clockwise to turn the coil 360 degrees. While we're turning it, look at the small diagram and compare it with the large one. So let's start by rotating it by 90 degrees, then 180, 270, and back to 0. And now let's select the field lines to show the white lines of force between the two magnets. In the small diagram, the lines change to black where they pass through the coil. Let's rotate the coil again, and for each 30-degree step, look at the small diagram to see how the number of lines going through the coil changes. So, for the first 30 degrees, 60, 90, at 90, the number of lines reduces to 0. At 180, all the field lines are passing through the coil. Let's increase it. At 270, there are no lines passing through the coil. And till reaching the 0-degree position again. So at which angles does the coil pass through the largest number of lines of force? Yes, at the 0 degrees and 180 degrees. And at which angles does the coil pass through the smallest number of lines of force? Yes, at the 90 and 270 degrees. Now let's select flux through coil and rotate the coil again. Look at the indicator and the small diagram as you rotate it. So, as we're rotating, there is a change in the flux through the coil. How many squares are lit up at 0 and 180? So this is the 0 position, and this is the 180-degree position. How many squares are lit up? Yes, 8 squares to the right at the 0-degree position and 8 squares to the left at the 180-degree position. The flux reading changes to a -1 because at 180 degree, the flux is passing through the coil in the opposite direction to the 0-degree position. Because the flux through the coil is changing as it rotates, an electromotive force should be generated in it. The induced electromotive force will be greatest when the flux is changed at the greatest rate. How much does the flux indicator change when the coil moves from the 330-degree position through 0 degree to 30 degrees? Let's check it. So from 330 to 0 to 30. So it changes from 7 squares to the right to 8 and back to 7. That's correct. How much does the flux indicator change when the coil moves from the 60-degree position through 90 to 120 position? Let's investigate it. From the 60, where it has 4 squares, through 90 to 120. So what's your answer? Yes, it changes from 4 squares to the right, then to 0 at the 90-degree position, and then to 4 squares to the left at the 120-degree position. Therefore, the greatest rate of change of a flux occurs when the coil is near its horizontal position, and the least is when it's near its vertical position. Hence, the induced electromotive force should be greatest when the coil is horizontal and least when it's vertical. That's all. Thanks for watching.